Hi everyone, thanks for joining this session. So I'm SCHUTZ. I'm with Patrick Masse. We are both part of Hewlett-Packard Enterprise EMEA Cloud Pre-Sales. So during this session, we'll discuss about how to enable cloud-native application thanks to Docker infrastructure and DevOps. So just to set the scene, and you probably have already seen that, but we are discussing about digital transformation, so the fact that it's impacting all industries, from telco to finance to retail, and most of the names that we are highlighting here should feel familiar. What all these actors have in common, so they are powered by a software platform, and what they have in common also is that obviously the code is great, but the user experience is also key. But all these applications are kept fresh. So they go through some constant code change, and they are keep up to date. And they are running on the common consumer device, from tablet to smartphone, in some case even from watch. If you are looking at the kind of industry problem, most of the large enterprise needs to take quite some time to deliver a new application. It can take up to a couple of months, up to 6 months. And what most of the enterprise wants to do is somehow mimic the born in the cloud startup, or some of the big names that we are highlighting, which are constantly updating code and delivering code update on a daily or hourly manner.
So how do we manage to be so agile in these applications that Christian has just mentioned? Is on the way the application resources are reserved to ensure application executions. So we have the traditional way where in an imperative manner you would define, set up the resources, the dependencies, step by step for your OS, for your hardware, for your different database, application server, and a web layer typically. That will be step by step in a sequential manner. As we go to cloud native, you would want to really leverage the dynamicity of the cloud resources, allocated resources. And that will be by delegating the setup of those dependencies to your applications, letting the platform to automatically set up the dependencies and the software for the application to run. And this is what is implemented using a declarative model. And this is what you can see in all the container as a service or platform as a service implementation that we are using today. Docker, Kubernetes, Cloud Foundry, name it, all are using the concept of manifest files where these dependencies are defined, letting the platform to automatically scale as required.
Okay, so to enable these cloud-native apps, so you need a platform. It can take different shapes. So here we are highlighting, either container as a service or platform as a service. If you look at the commonality between these two platforms, they are all running on IaaS infrastructure. Could be a private or public cloud. Powered by OpenStack, could also run on some of the public clouds such as Azure or Amazon. All these platforms are running on top of a container execution engine. Here also, just highlighting Docker engine or other alternatives such as Rocket OS. They leverage an orchestration layer. Could be Docker Swarm, Kubernetes, or Mesos. And they provide either container lifecycle management or application lifecycle. Usually on top of that, they integrate with a CI/CD tool, and they may integrate also with some catalog of apps or catalog of services, which allow to put together the application in a simpler manner.
So, and at the heart of container as a service, which is also reuse in the platform as a service, is the container lifecycle management. And containers, why containers are so interesting in so calls these days, is that they implement efficient, fast start-stop execution cycles for efficient dev test cycles in a continuous integration pipeline. You have a standardization of the packaging, which enables a distributed common software and software repositories without having to rebuild the things every time or at every cycles. And 3, you have the portability that enables the multi-environment setup, either private or public. So as you can see here, you have faster cycles. That enables more right to fail because you have more capabilities to include fixes in an agile manner. This means more innovation and higher quality and reliability for your applications.
Okay, so Patrick presented you the container as a service. Here I'm just highlighting the open source platform as a service, Cloud Foundry, which as it hurts is it'll give you a choice of cloud. So it's cloud agnostic. You can run it on private, public, managed. It's also agnostic of the development language, so it can support multiple framework, and it can hook with some backend application services. Here we are highlighting, RHP, Cloud Foundry distro, which is called Staccato, which is running, on different infrastructure as a service. Again, could be a private cloud based on OpenStack, could be a public cloud based on OpenStack, or some alternative. At the heart of this solution is, Docker, which pretty much is the environment where the application gets executed, and then surrounding that, you have the support of different language. Very simple mechanism to add additional language via a mechanism of build pack. The capability to connect backend services, think your database services, message queue, file system services, and then CI/CD that can integrate with this type of solution. So
among the different IaaS layers that we have, OpenStack is really a very interesting one. And as you know, in the OpenStack summits, the container and plus OpenStack topic is quite hot today. So we have different manner to consider container as a service and containers in the context of OpenStack. So first, as a compute resources, we have Magnum that enables the orchestration of compute resources via Docker containers today, or Mesos or Kubernetes environments. Or you can choose to simply deploy Kubernetes clusters thanks to the Merino application catalog. So both ways are cool ways, easy ways to deploy your containers as compute resources. But as we have seen, it's very interesting to leverage the containers to facilitate upgrades, fast cycles of your containers. So what about deploying your OpenStack controller plane as containers? That's exactly what Cola is doing with Docker containers, either on virtual machines or bare metal. Since it's quite a hot topic, we have other interesting projects that are addressing similar control plane containerized deployments. One interesting is one supported by Migrate, which is the containerized control plane, where Kubernetes is used to deploy your Docker containers and your OpenStack control plane. Staccato is supported by CoreOS. They have chosen to leverage also Kubernetes, but also Tectonics and Rockets as a container runtime engine. At the third plane, we have the networking, which interconnect either your compute containers or your controller containers. This is enabled by Courier, which maps the container networking API to the OpenStack Newton API, Neutron API.
Okay, so just to finish and give you some kind of high-level view of one of our customers. So it's an automotive customer. As an automotive customer, they have a vision to enable an ecosystem of application to realize kind of the vision of connected cars. So think of applications that will use some location geofencing mechanism and find based on the state of the road, the weather forecast, different information, what the driver may want to find. They have enabled their CI/CD pipeline. At the heart of the CI/CD pipeline, you find Cloud Foundry, and connected to some GitHub code repo, connected to Jenkins. Basically, what's the fundamental needs that they want is they are doing developing and QA of their application on two public cloud, Amazon and Azure, and they're using the capability of Cloud Foundry to easily redeploy some of these apps in production on a private cloud based on VMware.
In any case, your applications, whether traditional or cloud native, needs an actual infrastructure to run. So this transformation doesn't occur in one day. So we have still today traditional silos with dedicated hardware and to run in a guaranteed manner your applications. But as the move to cloud goes, there's another way which more compute units are defined to, ensure more portability of your applications and more, agility of your application execution. But the final goal is really to implement microservices type of design where your application is really split in microservices, and you will be able to leverage the capability either on private or on public cloud to compose your infrastructure based on your microservices requirements. That's really where you really deal with infrastructure as code. So as you can see here, either container as a service or platform as a service, but plus infrastructure as code type of model, this is the way that your application from an operator's standpoint will have the real control of the costs of your infrastructure, your security of infrastructure, and all these aspects. Leaving out the developers really to go serverless and really forget about where the applications are really running. This is the way that the development and operations really enable business application development. Thank you.
With that, thanks.